into account, but I just to make it quicker, I just times them all together. So. And so then, once I came up with the common denominator, I had to convert like the top part, the numerator. So I took 16 and I times it by 9 and 17, and I got, and then I took the 5 and I times it by 33 and 17, and I got 5. And then the last one, I times it by the 9 and the 33, and I got, so now that they're like all really big numbers, I just looked at them and figured out which one's the largest. So this one's the largest, and then this one's second, and then this one's the smallest. So it goes 5/9 is the biggest, then 9/17, and the last one's 16/33.
Okay, so it's easy to look when we have a common denominator, right? Okay, anyone else do it differently? Yeah, come up. And can you say your name?
Katie.
Katie. And what was your name?
Kershaw.
Kershaw.
Okay. Can I just do it right here?
Yeah.
Okay. So the first thing that we did, we kind of used our calculators, but after the fact. Oh, I'm putting them in order. Sorry. Okay, so the first thing that we did was we looked at each number, and since we're supposed to know the 1/9, so we know that this is 0.5, because 1/9 you get 0.11, so you do 0.5, so 0.5 repeated. And then we looked at to see if this is greater than 1/2 or less than 1/2, and so it's a little less than 1/2. And then this one's the same, is a little less than 1/2. And so we know that this one is the largest, and so it's just between these two, so then we just kind of put it in our calculator and found out this one was smaller than this one.
Cool. So you're kind of a melting pot of all strategies.
Yes.
All different strategies. Okay. So you had some number sense in there. You said, hey, I can look and see which one is 1/2, another half, and then work with the calculator then. Okay. Anyone else have any other strategy? We had some people just do calculator, plug it in. I think in your guys' test, you guys probably aren't allowed to use calculators in sometimes. So, at least from what I remember, don't quote me, but sometimes you're not allowed to. So, how would you do that another way? Yeah?
I can't really draw it on the board, but what I did is I just went back to elementary school, slicing it up like a pie.
Yeah.
If we had 16/33, I knew that one had the most slices, and therefore I had to do the smallest, because all the pieces were really, really tiny. And then 9/17 was the next one up, because the pieces were bigger, and then 5/9 were the biggest slices I could get.
Okay. So you looked at it visually, and you said, hey, this makes sense to me, 33rds, 17ths, 9ths. Okay, I like that visual sometimes. Yeah, thank you.
Okay, I don't know, I'm just asking if this rule, like, the bigger the denominator, that means the smaller.
So the bigger the denominator, the smaller the decimal. So we could have something like this, say 144. You're going to answer your own question. Sonia. So we have 144 and 2. What does that reduce down to? 1, if we divide 144 into 2, we get 72. So would that always be the case if it's bigger? It's bigger here, and this is smaller, but are they equal? They're going to be equal, because what I did was I just divided by 2. I divided by 2, and 2/2 is 1. So it's just like the same thing. If you put this in your calculator, this in your calculator, it's going to be the same decimal. So that can sometimes be a little bit misleading, but some patterns you can look at. If you have, say you have 16/33.
Like, I think she's asking if it's like, if you get the simplified one, like 16/33, that can't be reduced. And
Okay.
none of the other fractions can be reduced because 33 is the biggest, the denominator. Won't it be the smallest out of the other two?
So if you look at it, I kind of see what your question is. If you look at it visually again, You split it up, that's the one that's divided most, right? But sometimes your numerator, the number on top, can be really small. And so you'll only have a really small piece of the pie occupied. And then 17, you don't break it up as much into pieces, but you can have a lot more that's occupied. So I would say not all the time. But you can look at that pattern and use kind of that sense that you're using and look at visually the way that I think that you're doing. So that makes a little bit more sense. Ask me a question if you're confused on that as we're going through. Okay. All right, so one other strategy that you could do was to compare the numerators. To get the numerators to be the same. Okay, so you could, instead of get a common denominator, get a common numerator, which kind of seems weird because we don't add when we have common numerators, right? We're used to the common denominator. But the way you can do that is you can do what you did there, multiply them all together, okay? And then you'll know how many pieces. You can get the same amount of pieces, but a different amount of sliced pie. Does that make sense? So say we have 33. What's 16 times 5 times 9 again? It's right here, right? So, oh no, that's the bottom. So what's 16 times 5 times 9? What was it? 720? Okay, so we have 720 over 33, 720 over 9, and 720 over 17. Okay, it's a little bit easier now to see which one is bigger, even though this is divided into 33 parts, this is divided into 9. You can look at it visually in that way as well. Does that make a little bit of sense? It's not the most natural way to do it in my head, but it may be in yours. Okay? Alright, so we're going to take about 5 minutes to do this activity, and I want to make sure that you guys have enough time for the last part of our lesson. So Brother Piper wanted to have you guys get up and moving and order yourself around the room. So